Let's see. So to begin with, what you always want to do is a vertical asymptote is going to be where you're undefined. So you're looking at the denominator and figuring out what makes it 0. There's one thing you have to be careful about, and that's that you really have to reduce first. There's sometimes what will happen is you'll factor and a factor will cancel out. And that's real important when that happens. I don't know if it's going to happen on this problem, but it might. So what we're going to do on this, let's go ahead and start by trying to factor the denominator. Okay, and this is just kind of a trial and error trinomial is the way I look at this. First term is 2x squared. So that would be 2x and x. Last term is 3, so that's 3 and 1. It's not too hard if your numbers are small. So I think that will probably go like that. And then you're trying to get that inner term of x. So notice that inside term from FOIL is 3x. Outside term's 2x. Okay, you can make that happen, can't you? Okay, so you can make 3 and 2 add up to 1 if you have a positive 3 and a minus 2. Okay, so what the factoring of that trinomial would be then is 2x plus 3x minus 1. Okay, so I'll make sure that you're solid on even that kind of trinomial. Now what happens on this, and this is real important, is you're not going to have two vertical asymptotes. What's going to happen is that's going to cancel out, and this thing right here, when you have this 2x plus 3, and you set that equal to 0, that's going to give you a hole in the graph. It's not a vertical asymptote, so you could solve this pretty easily, and what you would end up getting is x equals negative 3 halves. That will be a hole. I'll show you on the graphing calculator on this in just a minute what I mean by that. Okay, the one that cancels out is not a vertical asymptote. The one that's left over is the vertical asymptote. Okay, so now what you do with this is you just go ahead, that would be x minus 1 equals 0. Of course, you can do that in your head if you want to. So x equals 1 is your vertical asymptote. So the one that cancels out's a hole, the other one's an asymptote. Okay, let me get my calculator set up here. And go ahead and put that in your calculator if you brought your calculator with you so I can show you what I mean by that hole. Oh, come on. And I think you can probably just do this in a standard window. Be sure you have parentheses around the top and bottom. And what you'll see is the only thing you'll see on your calculator probably is is a break in the graph one place. That's all you'll visually see. So let me go ahead and get this set up and I'll put together. Okay, so let me get this put in. So we're going to go 2x plus 3 in parentheses. That's important you have that in parentheses. Same thing in denominator in parentheses, so that is 2x the second plus x and minus 3. Okay, so just standard windows. So this is what I'm mainly wanting to show you is this then. So you're going to see the vertical asymptote coming out at 1. Now I'm going to just kind of slide this graph over here at the side so I can kind of explain what's going on here. You don't need to draw a picture of this graph unless you want to, but what happens on this is you have a vertical asymptote there, but what you have is at negative 3 halves, and negative 3 halves is like negative 1.5, you have a little hole there. You have a little bubble. You are undefined there. So let me show you one other thing on the calculator. If I was to go through and trace at negative 3 halves. I'm going to type trace negative 3 halves. Let me show you what happens, okay? If I trace, I get nothing. So it's undefined there. So this graph, this function's undefined at 2 places. One in negative 3 halves, but only one of them's an asymptote. Does that make sense? Okay, the one that cancels out is a hole. Okay, and that will be always the way it works out on that. So be careful about that. Before you find your vertical asymptote, simplify first. Okay, is everybody with me there? Okay, whichever one cancels out is the one that's going to be a hole in the graph. All right. Okay, so that kind of wraps up vertical asymptotes. I just kind of gave you some different examples of what can happen. Now we'll move on into the horizontal asymptote. And I'm going to show you two ways to do this. I'm going to show you kind of the approach that you like to teach a calculus student. Then I'm going to show you a set of rules that you can learn where you can do this automatically in your head. Okay, so first of all, when I do this problem, go ahead and just put this one in your calculator so I can show you what I mean by a horizontal asymptote. So you can wipe out the old one and just put in 3x plus 1 and then divide by x minus 3. Again, make sure you got everything in parentheses this way. And I want to show you kind of what happens on this. And I'm going to, again, just kind of slide my graph. You don't need to draw a graph on this on your notes unless you want to, but I want to show you basically what's going on this problem. So the idea is you have a vertical asymptote at 3, right? You're undefined at 3, so you can pretty well tell by looking at your graph that there's a break in it like this, okay? Does it look like the graph as you go to infinity is kind of leveling off? Does that kind of look that way to you? Okay, that's what's happening. And what's going to happen is the further out you go on this graph, the closer it's going to get to 3. Okay, I can tell by looking that horizontal asymptote's 3. I'll teach you that in a little bit here, but that's the basic idea. So what would happen, and I'll just show you this on the calculator, if you went to your table of values, and if you just started scrolling down, you don't need to do this, I just want to show my point here, is the further up I get, see how that thing's getting closer to 3? And it always will. So that's what a horizontal asymptote is that tells you what happens to the graph way out there and way out there at infinity, at the extremes. That's what a horizontal asymptote basically is then. Okay? All right, does that make sense what I mean by a horizontal asymptote to everybody? Okay? All right, so they're different. Vertical asymptote and horizontal asymptotes are two different things. So what I'm going to do is show you, first of all, the long way to do this. I think everybody needs to know how to do this before we do the shortcut. So what I'm going to have you do is we're going to divide the numerator and denominator by the highest power of x. The highest power I see in this problem is x to the first. If there was x to the second, that's what you would use. So what I want you to do to start with is just write down your problem. And what you're going to do is you're going to divide each part by x. Okay, because what you're really doing is you're multiplying by 1 over x. So you can do that. You can break up each part like that. Okay, and then what we're going to do is we're going to simplify that expression. Then I'll show you kind of what happens here. Okay, so some simple things happen. Right there, the x's cross out, that leaves 3. 1 over x, there's not a thing you can do with that, so you just leave that alone. If you go to the bottom, x over x is 1, and then you're left with 3 over x like that. So that's kind of the idea of what happens in that problem. Then I'll show you how to finish this up. Everybody understand what I did so far? Okay, now here's what we do. We're going to kind of let x become an infinitely big number. And what's going to happen is if you look at these two pieces of the problem right here, when x gets infinitely big, something happens to those two things. So like if you have 1 over x or you have negative 3 over x, if you put in an infinite number, do you know what that goes to? If you take 1 divided by something infinitely big, you know what happens? It gets smaller, but it gets close to some number. Do you know what that is? 0, right, okay. And one way to just show this to a student is like this. Okay, anytime that I take 1 divided by a bigger and bigger number, like there's that number there, it's already in scientific notation. That problem right there just means it's a 1 with 5 decimals before it. And if I was to go through and put bigger and bigger and bigger and bigger and bigger numbers in it, okay, it just goes to 0. Okay, does that make sense to everybody? And it doesn't make any difference what that numerator is. If the numerator is negative 3, it doesn't make any difference. If the numerator was a quadrillion, it still wouldn't make any difference. Okay, so it goes to 0. So you want to understand that concept. Both of those things go to 0. All right, so here's what happens then. You would end up getting 3 plus 0 over 1 minus 0. So you get 3 over 1, therefore you get 3. Okay, so we would say the horizontal asymptote is y equals 3. Now that's the long way of doing this, okay, and that's kind of what you do in a calculus class, but in a little bit I'll show you a rule that has something to do. So you can see that 3 in the problem, and I'll show you how you can figure that out in your head in just a minute here. Okay, does everybody follow what I did on that okay? All right, okay, you divide by the highest power of x, simplify, then you let x go to infinity, and some of those things are going to go to 0. That's what you're going to find happening, okay? Any question on that? Are we puzzled or okay? Tell me. Are we awake? Okay, all right, okay. Okay, let's do one more like that, then I'll show you the shortcuts. All right, so what's the highest power of x in this problem? X to the second, good. Okay, so that's what we do first. So step 1, what you want to do is you want to just write down your problem, and you want to divide every piece of that by x squared. And something a little bit different will end up happening on this. It's very similar though, okay? So you just divide by x squared. Then we're going to simplify each individual piece of this. So you got to make sure you know how to simplify all this stuff then, okay? All right, so what happens on this one then, if you look at these pieces right here, like this first piece right here, if you're doing x over x squared, now you can do that in your head, but what happens is one of the x's crosses out, so that's 1 over x. Okay, so that thing is going to be 1 over x there. This thing's already simplified, so you just bring that down as 1 over x squared like that. Can't do anything with that. If you go down the bottom, there's 2 things you can do. X squared over x squared, of course, is 1. Anything divided by itself is 1. And then there's x over x squared again, which is 1 over x. Then we have minus 5 over x squared like that. Okay? So that's as far as you can take that thing and simplify it, is like that. Then what you want to do, so after you've kind of done that, then really the second key thing you've done is you want x to just go to infinity, and you can learn to do this in your head. What happens on this is all of these things that I'm highlighting are all going to go to 0. Okay, because the idea is if you have a number over some power of x, it doesn't even matter what that power of x is on this, then that's going to go to 0. Okay, so all of these things go to 0 that I highlighted. So what you would end up having then is you would have 0 minus 0 over 1 plus 0 minus 0. That's 0 over 1, so it's 0. Okay, so what you get is you get a horizontal asymptote of y equals 0. And what that means is if we graphed that function on our calculator, it just means as x goes to infinity, the graph would get close to the x-axis. That's what the meaning of that is then. Okay, you guys understand what I'm doing? Okay. Okay, the infinity thing sometimes a little bit new to students, but the idea is any number divided by an infinitely bigger number is 0. Okay, that denominator is going to be infinitely big, so that's the idea. All right, now you can do the problem that way, or you can just learn the rules. I don't care which way you do it. I think it's good to understand how to do it this way, but you're probably most of you just going to use the rules, but you might forget this, and if you forget it, this is a way to figure this out. Okay, so on the next page, I'm going to just go through the set of rules and run through that. The rules are real easy, and it turns out these are the things that you have. You have 3 cases. So the first thing is you just look at the degree of the numerator, and the degree is the highest power. So if the degree of the numerator is less than the degree of the denominator, then that's your answer automatically. Okay, y equals 0. Now let me scroll back to the problem we just did so I can show this to you. Okay, so if you look at this problem right here we just did, the degree of the numerator is 1, right? That's the biggest power. The degree of the denominator is 2. So since that degree is smaller than that, the answer is 0 automatically. Okay, so you don't have to do that. You can just, boom, okay, I got the answer. That's the way that goes. So that's case 1. We also did case 2, and I'll show you how that goes. Case 2 goes like this. This would be if the degree of the numerator and denominator are equal, then it ends up being a ratio of what we call leading coefficients. So let me scroll back to the previous page and show you what we did and how you could have done that example in your head. Okay, so if you look at this example 1 we just did, the degree of the top and bottom are both 1, aren't they? Right? Okay, so the answer automatically is the coefficients. The coefficient of 3x is 3. Coefficient of x is 1, so it's y equals 3. Problem done. Okay, that's how you can do that. But that only works if the highest power of x are the same in the top and bottom. That's why most of you are going to do it. It's like this, the way I do it, because I can do it in my head, and I can do it real fast, see. Okay, so the third thing that can happen, there's only 3 things that can happen. This would be if the degree of the numerator is larger than the degree of the denominator, then you don't have one. Okay, there is no horizontal asymptote. Now, there's one thing I do want you to add on this. I thought I added this on here, but you need to. There is an oblique asymptote if, and you need to write this on here, if the degree of the numerator is greater than the degree of the denominator by 1. Okay, it's got to be 1 bigger. And what an oblique asymptote is it's a line. It's a slanted line. So sometimes you'll hear, well, a textbook sometimes will call this a slant asymptote, like that. So those are the 3 cases that you're going to have. So what I'm going to do next here is just we're going to do problems that we can do in our head now. And then this is an important part of the graphing that we're going to learn. So it all depends on what the degree of the numerator and denominator is. That's how you can figure all this out. Okay, it's simple. Okay. All right, so let's look at this example 1. Tell me what the degree of the top is and bottom. They're both 2, aren't they? Okay, remember the degree is the highest power, so they are equal. Okay, since they are equal, the answer is staring you right in the face. Okay, what is it? If they're equal, then there's your answer right there, 3 over 2. Okay, it's the ratio of the leading coefficients, so you get 3 over 2. Okay, what that's going to mean, if you put that in your graphing calculator, if x goes to infinity, then the function goes to 3/2. Okay, so it'll level off at 3/2. It'll never hit 3/2, but it'll just get closer and closer to it like that. See how easy that is? Okay, that's why you're going to do this, is just probably learn the rules. And by the way, this stuff turns out to be kind of a real big deal in Calc 1. I can think of lots of times beginning of the semester when we use this idea when we're doing limits. So it'll certainly show up. Okay, next one. Let's see what this one is then. Okay, what's the degree of top and bottom on this? They're both 1, right? So since they're equal, can you tell me what the horizontal asymptote is? 1/3, right? Okay, that's a 1 there. So it's there. So y equals 1/3 would be the answer. Okay, so that's, you got to identify that it's that case. All right. Okay, next one here. Okay, so what's the degree of the numerator and denominator? 1 and 3, okay. So this is a different case. So what you would have here is, since the degree of the numerator is smaller than that, the answer is y equals 0. Okay, that's how you get it automatically. So anytime you see that, that's a guarantee on the problem. Okay, that's how that works out. Okay. And then the last one on this page, degree of the numerator is 2, degree of denominator is 1. So since the 2 is greater than 1, we said that there isn't 1. Okay, those are the 3 things that can happen. Now, we're not going to worry about the oblique asymptote yet. We'll get into that here in just a minute here, on how you do that. So that's how that works out. There's 3 rules. Once you get those down, you can do this in your head just like that. All right, everybody with me okay? Okay, or you can do it the long way if you want to. I don't care, okay? All right. So I think the other thing we're going to talk about is just going to finish this section up with oblique asymptote and kind of talk about how that goes. There's times in Calc 1 when you're doing limits where a lot of times I teach Calc 1 and I can tell students don't know the asymptotes as well as they need to, and that's the key to figuring out the limits and stuff you do in certain calculus problems. So first of all, can you tell me why this has an oblique asymptote? By looking. What's the deal with the degrees? It's bigger by 1, okay? So remember what happens if the degree of the top is greater than the degree of the bottom by 1, then you have an oblique asymptote. Now, if that was, and that is a 3, and I wrote over that, so yeah, okay. Yeah, you'll have an oblique asymptote. If it was bigger by 2, then you don't have one. You have something else. You have what's called a quadratic asymptote, and so forth, which can get kind of interesting. All right, so we're going to do a long division problem. Now, remember, we learned long division and synthetic division. Synthetic division is a lot easier process, but you can only do synthetic division when you're dividing by x plus or minus a number. Unfortunately, we can't do it here. Okay, that's x to the third. So synthetic division's out of the question here. So what you have to do is you got to set it up. All right, so what I want you to do is we're going to set it up like this. Not synthetic division. You got to put all the powers in there and everything. So we got this. Got an x squared. We don't have an x to the first. And if you don't have an x to the first, it's helpful to put in a 0x. Although you can get by without doing that if you know what you're doing. Okay? And then on the x to the third, now you don't have to put up the missing terms on that. You can just put x to the third like that. Okay? And then I'll kind of go through this long division process that we learned how to do. And, you know, everybody's got to know how to do long division in calculus for certain reasons. So I'll kind of just write down the steps. You guys don't need to write down the steps. You're ultimately trying to do this in your head anyway. But if you feel like you need to write down the steps, then you can. So step 1 is you always start by dividing those two things. Okay, and you just, once you practice this, you get to where you can flow through this pretty quickly in your head. Okay, the result of that is 2x. Okay, and that's what's always going to happen. Our answer is going to look like y equals mx plus b. It's going to be a line. So that becomes 2x. All right. Step 2 is we multiply. So we're going to do the 2x times the x to the third minus 1. All right, that just doing a distributive property. So that would be 2x to the fourth minus 2x. Okay, and again, you can do that in your head, but when you write that result, put it under the like term. So that's 2x to the fourth. The minus 2x, I would put that way over there so it lines up with that like term, like that. Okay. So you divide, then you multiply. Then the next thing you do is you subtract. Okay, and what's going to happen is this. Now I'm going to write this in. This is really, you don't have to do this, but if it's helpful to you, you could think of those missing terms like that. Okay, then we're going to subtract like this. Okay, so what I'm doing is I'm just doing 2 minus 2. 2 minus 2 is nothing. That thing will always cancel. It always will. Then here I'm doing, really technically, I'm doing negative 1 minus 0. So that's just negative 1x to the third. Same thing here. That's going to be x squared when you subtract it. And then this is where you got to be careful. This is the most common place students mess up is right here. You're really doing 0x minus negative 2x. So it's really 0 plus 2. So that part right there is going to be plus 2x. You've got to watch how you do the subtraction because sometimes you subtract a negative number. Okay, that's the key. So we got that. So I have made it through one loop through the problem, and then you always just kind of close that off by bringing down the next number. Okay, that's always step 4 is just to bring down the next number. Okay, so if you're doing this, sometimes students do way better on these problems if they write down the steps the way I'm doing, you know, until you get to a point where you feel comfortable how you process that in your head. We only got to find one other part of the problem, by the way. So the idea here is next thing we do when we start over again is we do that division. I'll kind of write the steps over here at the side. So now we do negative x to the third over x to the third like that, and then that result is -1. So you just put it up there somewhere like that, and we're really done. That's really your oblique asymptote. It's y equals 2x minus 1. I'm going to finish the problem up because I want to explain something about this problem, but technically you could stop there. If it's an oblique asymptote, once you get the mx plus b, you're done. You don't have to worry about the remainder. I'm going to go ahead and finish this, though. So the next thing we would do is we would do -1 times x to the third minus 3. So I'm going to multiply that. So that's -x to the third plus 1. Record what you have. That would go there. The plus 1 would go all the way over there like that. Okay? Now, what will end up happening on this when you subtract, that'll cancel. This part right here is going to be -1 minus 1, so it's going to be -2. And all of these things just come down. Okay, because there's only a 0 underneath that, so you end up getting that then. Okay? Now, what's going to happen here, and I'm going to erase this stuff here. You didn't need to write that down necessarily. But I want to explain to you really what you get on this problem. What you really get is you get 2x minus 1, and this thing right here is the remainder. This whole thing right here is the remainder. So what you do is you say plus x squared plus 2x minus 2 over the divisor, x to the third minus 1. Now, you guys, when you're doing your homework, you can bypass this. I'm showing this because I want you to understand this. What happens is if x goes to infinity, then this whole thing right here goes to 0. Let me explain why. All right, let me explain this right here. Okay, what's the degree of the top? 2, right? What's the degree of the bottom? 3. If the degree of the top is less than the degree of the bottom, that thing goes to 0 when you go to infinity. So what happens is, there's your answer right there. You can actually bypass that, because anytime you have an oblique asymptote, it's a line. So once you get to the 2x minus 1, you can stop. You don't have to proceed any further. Okay, so what we'll have then is that answer would be y equals 2x minus 1. Okay? Now, I do want you to put this in the calculator. Before I do that, does anybody have a question about what I've done on that? This stuff right here sometimes takes a little time and practice for students. I see that pretty frequently on the long division, because you can't do it synthetically. But you write your steps down very carefully, and once you get to that line, you're going to be okay. All right? Let's put this in the calculator, because I do want you to visually just see what goes on this problem, because it's helpful to use your calculator to understand this stuff. So go ahead and just put it in. Put the numerator in. So that would be 2x to the fourth. And let's see, minus x to the third. And plus x squared. And then minus 1. And let's see, divide by x to the third. Minus 1. It takes me forever to put stuff in this calculator. Get over there, get over there. Okay, just do it in a standard window to start with. And we'll kind of see what we see here. All right, so first of all, do you see a vertical asymptote? Do you see like a break in the graph where there could be a vertical asymptote? Yeah, there's one right there. But what happens is this graph is not leveling off, so it doesn't have a horizontal asymptote. So I want you to also do this. Okay, this will be visually pleasing, at least to me. Put in the 2x minus 1. So go to y2 and put in the 2x minus 1 and just graph it in a standard window, and I'll show you kind of what I want you to see on this then. That kind of turns out nice, just as a decent example to show students. Okay, so what's happening on this problem then is an oblique asymptote works like this. So basically, the idea is as you go to infinity, what's the graph doing? The graph's just getting close to that line. As you go to negative infinity, the graph's also getting close to that line. That's what an oblique asymptote is. It's a line that slants and then goes like that. Now, the vertical asymptote if you look at this problem that we just did, you were undefined at 1. If you look at that denominator, you're undefined at 1, so you also have a vertical asymptote coming out at 1. Okay, does that make sense? What I mean by an oblique asymptote. Hardest part of that problem is doing that long division, but once you get the hang of how to do that, it's not that bad. It does take a little bit of work since you can't do that synthetically. Okay, so let's look at the next one. Okay, now the thing on the next one is, I'm going to ask this question. Okay, first of all, there's an oblique asymptote because the degree of the top is 1 bigger than the bottom. Everybody with me there? Can you do this one by synthetic division? Yeah, so let's do it, okay? And that's because it's x plus 2. So this one we're just going to do by synthetic division. So if you can do it, then by all means do it. You have a missing term. So we're going to put 1, 0, negative 1. What do I divide by, 2 or negative 2? Negative 2. And remember, if you set that denominator equal to 0, that gives you negative 2. So you got to make sure that you get the sign right on that. And then the nice thing about synthetic division, it's just super easy. So you bring down the 1, negative 2 times 1 is negative 2, add the column, multiply, which would be 4. Okay, add and you get a remainder of 3, which is okay. You're going to get a remainder. So what this means is, this is your remainder, this is the constant term, and then that is x to the first. Okay, so what you end up with is you end up with 1 x to the first minus 2, and then you have a remainder of 3. So really the answer is right there. It's the linear part. The remainder doesn't have any bearing on what that slant asymptote is. So the slant asymptote or oblique asymptote would be y equals x minus 2. Okay, that's it. Okay, that's the idea. Okay, so it's a little bit easier if you can do it that way if it's synthetic, but you can't always do that, so you got to be fairly flexible on how you do that. Okay, is there any question about what I did there on that? Were we okay? All right. Okay, so I kind of wrap this section up on the next page, and then we'll get into the graphing part here. This one I'm going to not really figure out the oblique asymptote on this, because the thing is you don't have an oblique asymptote. Can you tell me why you don't have an oblique asymptote? Because the degree is too bigger, okay? Yeah, and you can write a note of that if you need to. So the degree of the top of the fraction is 2 bigger than the denominator, so that's why you don't have that. Now, I do want you to put this in the calculator because I want to just show you something. This is probably a fairly good example. Sometimes I take the time to show this. This one I think I'm just going to show you on the calculator. So just put this in, and I'll show you kind of what happens. There is an oblique asymptote, but there is a different type of asymptote on this. And there won't be any vertical asymptotes on this one either. Okay, just do it in a standard window. And I want to show you, I'll see if this thing is pretty reasonable here. So, well, that's kind of interesting the way that one worked out. I wasn't thinking it would quite work out like that. Actually, what would happen on this, and I'll tell you this, is you would end up having, on this problem, you would have an asymptote that's a parabola. And this is not the best example. There's probably other ones I could have came up with that are better. So if you did the long division, if you divided, you would end up, this is kind of the key thing that would happen, is you would end up with y equals x to the second in there. So what happens is, on this particular problem, as x goes to infinity, it approaches a parabola. Okay, so if that degree is 2 bigger, it's a parabola that acts as an asymptote. If it was 3 bigger, what would happen? It'd be a cubic that would act as an asymptote. That's the idea. Now, we're not going to deal with that very often. That's just something I want to show you. So that one would not have an oblique asymptote. Okay. Okay, so just to kind of wrap this up, on this, these are just some asymptotes, so just which is which. You want to make sure you know the equations of this. So this one has two vertical asymptotes, one of them at x equals -2, and the other one at x equals 6. Vertical asymptotes are vertical lines, so they're named by the x value. The horizontal asymptote on this one is named by the y value it goes through, so that is y equals -2. This one does not have an oblique asymptote. Okay. The next one, it does not have a horizontal asymptote, nor does it have, I think that was intended to be vertical asymptote, but it does have an oblique asymptote. Okay. So if you wanted to figure out the oblique asymptote on this, well, it's a line, so it's y equals mx plus b. You would just have to estimate the y-intercept and estimate the slope. So it looks to me like the y-intercept is 1. And for the slope, 1, 2, 3, I'm going to guess that it's 3 over 1, up 3 over 1. So it looks like that slope is 3 over 1. So what you would end up getting is you would get y equals 3x plus 1. So that's an example of an oblique asymptote. Okay? All right, any questions about what I've done with this so far? Okay, this particular section just has a lot of properties, and we don't do any graphing on this. What we do in the next section is we start doing the graph.